Question 8 of this exercise says that in figure 6.62 given alongside, two chords AB and CD of a circle intersect each other at the point P when produced outside the circle. So AB and CD, two chords, when they are produced outside the circle, they meet at this point P. We have to prove that in part 1, triangle PAC is similar to triangle PDB, and then in part 2 we have to prove that PA into PB is equal to PC into PD. So let's start with part 1, in which we have to prove that triangle PAC, which is this triangle that I am highlighting, this triangle is similar to triangle PDB. So observe the order of the vertices, PDB. Okay, so we have to prove that these two triangles are similar. So this is actually quite easy to prove because this angle at P is common to both the triangles, and then we will show that this angle PAC is equal to this angle at D. If you want, you can pause the video for a few moments and think about how we can show that this angle is equal to this angle. So once we have done that, we can claim that the two triangles are similar using AA similarity, and then by making use of the fact that the sides are proportional, the sides will be proportional, we will get the second result as well. Okay, so let's start with the first part. So to prove that this angle PAC is equal to the angle at D, let's consider this angle inside ABCD, this angle at A. So this angle, which is angle BAC, so angle BAC plus angle D will be equal to 180 degrees. Can you see why? So this angle plus this angle at D, their sum must be 180 degrees. And that is because in any cyclic quadrilateral, the opposite angles are supplementary. So ABCD is a cyclic quadrilateral. So angle A plus angle D must be equal to 180 degree. So let's write the reason: opposite angles in a cyclic quadrilateral. So this is the reason for this thing. Then we also note that angle BAC plus angle PAC, this is 180 degree as well, because these two angles form a linear pair. So angle BAC plus angle PAC is also equal to 180 degrees because these two angles form a linear pair of angles. So if you observe these two equations that we have written, the left hand sides must be equal. So on the left hand side we have BAC plus angle D and BAC plus angle PAC. So from these two equations we can conclude that angle D and angle PAC, they must be equal. Okay, so let's write this. So we conclude that angle PAC must be equal to angle D. Now let's compare the two triangles which we want to show as similar. So in triangle PAC and triangle PDB, so how can we show that these triangles are similar? As I said, angle P is common to both the triangles, so angle P is equal to angle P common, and we have just shown that angle PAC is equal to angle D, or let's write this as angle PDB. Okay, so this is something we have proved. So from these two we can say that triangle PAC is similar to triangle PDB using the AA similarity criterion. So this is what we had to show in part 1, that triangle PAC is similar to triangle PDB. So this completes part 1. Now let's come to part 2, in which we have to show that PA into PB is PC into PD. Alright, to prove part 2, we simply make use of the fact that in the two similar triangles PAC and PDB, the sides must be proportional. The corresponding sides must be proportional. So what are the corresponding sides? So if we take PA in triangle PAC, corresponding to PA, we will have PD. So PA by PD, and this will be equal to, if we take PC in the first triangle PAC, this will correspond to PB in the second triangle. So you can either observe this correspondence of sides from the figure itself, or you can use the similarity relation. So corresponding to PA, we have PD, and corresponding to PC, we have PB. Okay, so you can do it either way. Now we cross multiply, so PB to the left side and PD to the right side, and this will give us PA into PB is equal to PC into PD. So this is what we had to show in part 2. So this completes part 2. And by the way, this is an interesting result on circles, which basically says that from an external point, in this case P, if you have two secants drawn to a circle, then in this case the two secants are PB and PD, then the product of PA and which is the segment drawn from the external point to the first point of contact, so that segment into the entire segment PB is equal to PC into PD. So this result is actually a very important result from the topic of circles, and it applies to any two secants drawn from an external point to a circle. Okay, so with this we have completed question number 8. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.